Before we start creating everything, let's take a look at our final project and get a brief overview of what we will be creating exactly. So this will be the file that you will be provided with, and all of our effects will be created in this node, and from this node over here we will be exporting everything inside its own geometry container so we can render these separately. As far as our lights and camera goes, we have a simple camera which is linked to this null over here, which we will be using to rotate and orbit the camera around and create some zoom in and zoom out animation. And for the light we will simply use an HDRI light because most of the lighting will come from our lighting and ray sources. So let's go to the beginning of the frame and let's step inside this effects geo container and see what we will be creating. So here we have all of our nodes, and at first glance it might seem that this is a lot of work, and you would be right, this is a lot of work, there's no way around this. So because we are creating everything inside of Houdini, this is pretty much how a more complex scene will look like. Originally when I was developing this effect, this graph was even bigger, and I basically had to strip it down to only the essential parts. And because we basically have 6 or 7 different elements that are coming together to create the final look, so we have the ground geometry, we have 3 types of linings, we have the debris particles and the debris smoke, and then we also have the volumetric rays. There's already a lot of elements to take care of, and so this is the result. This also looks like a lot because I placed everything inside a geo container, so if I go back up and I go inside any of these other nodes, inside here there's only an object merge with which points to a node in our effects container. So we can see that there's only one node or a couple of nodes for each of these elements. So everything will be done inside this effects container, and you don't really have to do this. You can spread this out in as many nodes as you want, but the way I like to work is if I'm working on one scene, I like to create everything inside a container and then export all of the nodes to their different render geometries. But anyway, I will be taking you through all of this step by step, node by node, and I will explain everything as I go, and we will start from right over here, which will be our height field. So we will create a height field volume, which looks something like this, and from this we will be creating, so this is just a volume. If we look here, we are working with fields, and we will turn this into geometry. Okay, and then there is this height field collision, which we will use later as a collision object inside a DOBNet simulation. And from here we are optimizing this terrain a little bit, so we are cutting a hole where we want our main simulation pieces to be, and so this will be the interior and this will be the exterior. And over to the right we are going to be simulating a bunch of points, or not really a bunch but more like 5 points. And if I play this, we can see that we have 5 points that are starting from the center, and this is pretty much the base for our lining that spreads. Alright, and from this we generate some curves, which we will later reference inside attribute VOPs to set a different attribute for our fractured pieces. And from here we also generate a cutter from our curves. So this cutter will be used as our initial fracture for the geometry, and I can go over here. And here we have this separated piece, which we will use to create our main fracture pieces. But first we will optimize this even further, and we want to separate this into just a thin surface slice, which we have over here. So this we will start cutting up into a bunch of pieces. And over here we will have the base, and this will be used mostly for rendering and as a collision. So let's start over here where we have imported our surface. So this is the surface that we want to cut up. And first we will use this cutter that we generated from the curves that I showed earlier. And from here we generate our initial pieces. And I can preview this if I set the visualizer to name. These are our original pieces, and we basically need a cut right along where we have the lining interact with the geometry. So this is exactly the direction where our lining will go. And from here we iterate through this network over each of these 5 pieces individually, and we will create our main fracture geometry. So if I preview this, these are going to be our simulation pieces. And over in this node we have basically 3 layers of cutting. We have one that's using a grid, and then we have a cutter that's based on our original cutter that I showed earlier. And finally, we also have another one which is used to create more concentric cuts for the geometry. So we have 3 layers of geometry, and we will also place everything inside a compile block to make this run a lot faster. So after that, we cache the pieces, and maybe we can even drop here an exploded view so we can see these more clearly. Okay, and I can disable visualizer, and this will be how our fracture geometry will look. So from here we will optimize this, and we will get rid of some of the small pieces and further optimize our fracture geometry, and then we pack them and turn them into simulation friendly geometry, and we can preview this here. So we will run a convex decomposition to make our pieces run faster in our simulation, and then we will finally pack them and cache them out. So this will go inside our main DOB network for the simulation, and from here we bring out the pieces from the simulation network as points. So we have these cached over here, and then we can run a transform pieces and use our high quality geometry to link them to these simulated points. So here we have the simulation. Then we merge this geometry with our exterior geometry. So this will be our render geometry. And over here I also save this geometry as a Redshift proxy in order for our renders to move a lot faster. And this will be covered in the rendering section. Let's go over here to the right and see what else we have. This debris pieces network over here will be used as a sourcing for the rays, for the volumetric rays, and we will look at this in a second. And I also set up here a VDB collision, which will be used in our smoke simulation and our particle simulation as well. Let's go over here to our LTG strike. So this will be our first lightning strike, which is just this one in the middle, in the center of our scene. Over to the right we will have our lightning spread. This is the more complex lightning from our lightning effects. Okay, and to the right we have finally our last lightning element, which is this LTG static, so lightning static. This is just some of this lingering lightning after the explosion happens. Okay. And finally, to the right of this, we have our volumetric rays. And from here, the only things we have left is our debris. So we have our debris points. So this will be used as a source for the smoke simulation and also the particle simulation. And from here, we branch this out in the smoke and the particles. And here we have the smoke cached, and then finally we have our pop as well. So this will be sort of like the dirt. And also there's one thing I skipped over here. There should be, we have some rock debris. So this will be layered on top of our ground geometry. So we will just scatter a bunch of points, which we will then use a sphere with some noise to it, and then copy the sphere to all of these points, and then we will also simulate these on top of our main fractured pieces. So there's a lot to cover, and as I mentioned, we will be creating everything from scratch, as you can see, everything except the material which is provided inside the downloadable contents. So I hope you will enjoy this course and you will learn a bunch of new things, and let's get started with our first element, which will be this height field terrain. So this HIP file will be provided to you as well, and so if you get stuck anywhere along the course, you can always refer to this file and see exactly what settings I use and compare it with your version. So with that being said, we can get started now.